All right, the quiz question. We have a spherically symmetric charge distribution. Electric field is given. Let's calculate the electric potential. Okay, so for R greater than B, we are trying to find V of R integral E dot dl with a minus sign infinity to the position R. So it's a spherically symmetric, so it's radially symmetric everywhere. So we're going to write V of R equals, and the path we're going to take here is a radial path, minus infinity to R. And then I'm going to use this electric field, K over 4 epsilon naught, B to the 4 minus A to the 4 over R squared. Again, R prime squared, dr prime, because I'm taking dl as dr prime, R prime hat. Okay, so that's what we have. So let's calculate it. Minus K over 4 epsilon naught, B to the 4 minus A to the 4. And this is just simple integral 1 over R. So if you evaluate at R infinity, you get 1 over R here. So this is the first term here. The only thing is I forgot this minus. This is going to bring another minus R to the second half, R prime to the second power. So that will be minus 1 over R. And that's why this is positive. Okay. So A smaller than R, smaller than B. In this case, we need to go minus infinity to B, right? First here, and then to the point R. So again, E dot dl minus B to R, E dot dl. But we already calculated this. This is just V of B. Whatever function we have, it's the same exact thing. You just need to calculate this. So V of R, then V of B, which I can just replace R here with B. K over 4 epsilon naught, B to the 4 minus A to the 4 over B. Minus, now I have B to R. The electric field here is K over 4 epsilon naught, R prime squared minus A to the 4 over R prime squared, dr prime. Right? Again, I'm using integration variable R prime here. That's to differentiate from my position R. Okay, so we do that. K over 4 epsilon naught, B to the 4 minus A to the 4 over B. And then minus K over 4 epsilon naught. Here, this is R prime cube over 3. And this is A to the 4 over R prime with a negative sign, so this is going to be positive. Okay, so evaluate at B and R. All right, let's do some factoring out and a little bit of cancellation. Okay, this is B cube minus A to the 4 over B minus, when I have R here, I'm gonna have R cube over 3 plus A to the 4 over R minus B cube over 3 minus A to the 4 over B. Okay, open it up, K over 4 epsilon naught, B cube. There's another B cube over 3 here with a negative sign, so B cube plus B cube over 3 minus A to the 4 over B minus R cube over 3 minus A to the 4 over R, and minus plus A to the 4 over B. So this cancels with this. This is 4B cube over 3. So if we write the full function, we're going to get 4B cube over 3 minus R cube over 3 minus A to the 4 over R. Okay. So What if we go to R smaller than A? Well, let me write it here. R smaller than A. Well, we have it all the way to A and then go inside, but inside electric field is 0. So basically V of R would be just V of A. There is no contribution to E dot dl inside. So if we write that out, so we need to just replace these R's with A. So what we will have is K over 4 epsilon naught 4 B cube over 3 minus A cube over 3 minus A to the 4 over A, which is A cube. Okay, so for this region, V of R becomes K over 4 epsilon 3. There's another 4 coming from here, 4A over 3. So A's 4's cancel, K over epsilon 3, B cube O minus A cube over 3. Right, so that's our potential inside. It's constant, and that's what is expected. All right, let's verify these. Let's verify if we can recover the electric fields by taking the negative gradient. For R greater than B, okay, E is negative gradient of V. So since these are just R dependent, I'm going to just take the derivative with respect to R, partial derivative with respect to R, basically. So minus partial with respect to R of K over 4 epsilon naught B to the 4 minus A to the 4 1 over R. So it's just the derivative of 1 over R, basically, with a minus sign, right? That's minus 1 over R squared. Then there's another minus sign, just going to give you K over 4 epsilon naught B to the 4 minus A to the 4 over R squared, which is exactly the field that we started with. R between A and B, we have the potential here. So we're going to take the derivative of this function. So minus del R of K over 4 epsilon naught. So we have a constant for B cube over minus 3, and then I have R cube over 3, and then I have A to the 4 over R. Okay, so that's my E of R in this region. That's basically E sub R of R. That's the only component anyway. K minus K over 4 epsilon naught. The derivative of constant is 0. This one is minus 3R squared over 3. And this one is plus A to the 4 over R squared. Okay, so these threes cancel. So this minus sign can be distributed inside. So E of R would be K over 4 epsilon naught R squared minus A to the 4 R squared. Again, as we expected. R smaller than A is the easiest one. Because for R smaller than A, I have it constant. Okay, since V of R equals to V of A, it's a constant. So my expectation for the electric field is minus del V del R of a constant, which has to be 0. So that's what I have here. That's all verified. I hope you enjoyed the solution.